Hi friends, and welcome to this tutorial for beginners in SketchUp for Web. If you prefer to watch this tutorial divided in 4 smaller videos, please click on the card that appears above. This is the free version of the 3D modeling computer software SketchUp that runs in a browser, and it's a great start for people interested in learning this program. The web version, although is more simple than SketchUp Pro, has all the necessary features to make your first projects. In my opinion, once you stick to the tools and have a lot of practice, you may consider upgrading your account. But for now, as probably you prefer to not pay in the beginning, let's start. Okay, I organized this tutorial in a way that you can practice while you are learning. Because of that, I created exercise files which I add the links in the description of the video. While some are intended to explore the tools and features, others contain actually exercises to practice. Now, as you can see, this is the main interface of the application, and this large area where I make all the drawings is called the viewport. Let's open the first exercise file, Chapter 0, Interface. And for now, we are going to start talking about the mouse buttons. Now, one thing that I highly recommend to you is to get a mouse instead of using the touchpad. As you will see, the workflow will be much better. The reason is simple. A mouse has more buttons, and one that really makes the difference is the scroll wheel. Now let's see how the buttons work. With the scroll wheel, we can zoom in or zoom out the workspace, and the zoom itself also depends in the position where I have the pointer. For example, if I move it towards this man here, you can see that the zoom applies in that position. Now, let's see the left button. With it, I can select an object. For example, this box. Then, to select more than one object, after picking the first one, we have to press either the button Ctrl or Shift while selecting the second. And now I want to mention that it's very important to look at the bar below, the status bar, because no matter the tool that we pick, there is a sentence indicating what I should do next. For example, now it says click or drag to select objects. Then Shift to add or subtract, Ctrl just to add, or Shift plus Ctrl to subtract. However, I prefer just to hold Shift here, as it always works for both ways. The right button opens this right button panel that has several operations that we can perform. And at the top here, as it may be unnoticeable for the first time user, you can see that there are the tools for cutting, copying, pasting and erasing objects. Now, that right button panel may change depending on the type of object that you select. For example, I'm going to explode this box into its original objects. If I open the menu for a face, you can see that the options are different than when I do it for a line. Another important feature that we can do with the mouse is the selection area. And here, if you know how to use AutoCAD, it just works similar. First, I need to click in an empty space with the left button and hold it. When you move the pointer, you realize it opens a rectangle. That's a selection area. But now there are two ways. If I open it from the right to the left, all the objects that are partially covered with the area go to the selection. However, if I do it from the left to the right, and notice that the rectangle is continuous instead of dashed, I have to cover an object completely in order to select it. As SketchUp Free is a 3D interface, as the 2D view is only available for the paid version, we will need to use a lot the Orbit tool. With the help of the mouse, it's pretty easy. We only need to click and hold the scroll wheel in order to activate it, then just need to move the pointer to rotate around the workspace. To activate the pen tool while clicking and holding the wheel, I press the button Shift and the pointer switches to this symbol of a hand. And with that, I can easily move to the sides. Basically, zoom, orbit and pen are interconnected. And to be fluent moving around our project, it's not that easy as it may look at first. Sometimes in bigger projects, going exactly to the place where we want takes some time, and I recommend to start doing this with slow movements. Now let's proceed. In the main screen, you have for sure noticed this person standing at the origin of our coordinates. Currently there is this guy holding this instrument like a ukulele, but from time to time this person changes. The purpose of having the figure here is for having a better understanding of the sizes of the drawings. When I rotate the blue axis, you can realize that the person always faces us. But if I invert that direction and put all the drawings facing down, the same happens to the guy. Okay, now I want to make a brief introduction about the main menu and the toolbars. If you click in this button at the top left corner, here is where I have the main file options. I can access the home page to open one of my projects. I can open a file either from my device or from the cloud, the Trimble Connect, which is a nice feature because I can save the files directly here. Then I can see the options to save the file, import as a SketchUp file, a JPG or a PNG. I can export the file. There are all these options to choose from, or download it to my device. Below this line, I can find the settings of the application, which is one of the first things we should look at when we start using SketchUp. And that's exactly what we are going to focus on next. In this window, we have three sections: General, Accessibility and Navigation. Here, we can see at the top there is the option to autosave, which by default saves the file on the cloud every 5 minutes. Below, I can set the language that I want to use and the units. This one is especially important as from now on, every time I start a new project, it uses the units that I specify here. In my case, I stay with millimeters. Then, on Accessibility, I can change the colors of the axes. Notice that in SketchUp, they are not named as the common X, Y and Z, but instead as colors: blue, red and green. So I can change the color of any axis if I want, but remember that the axes keep the original name. For example, if I put the blue axis with a yellow color, it's still called blue axis. Then on the third tab, the navigation, I find the settings for my device. First, I will need to choose if I'm using the mouse or the trackpad, and edit some options, like switching the direction of zooming and the sensibility. And notice that the orbit and pen sensibility are not editable when the current device is a mouse. Now I can close the window, and the next thing we are going to cover are the toolbars. Now you can see at the sides two vertical bars containing icons. I'm going to start with the one at the left, which is the toolbar, and here is where I can find the tools for drawing or modifying objects. Similar tools are generally grouped in the same button. The arrow that you can see here indicates that I can switch to a different tool. For example, if I click on the line, which is this pencil symbol, I have the option to switch to a freehand tool if I need. On the arc tool, I can find 4 different ways to draw arcs. Or where I have the move tool, there is also the command scale and rotate. Also, by exploring these icons, you will notice some of them are a bit more transparent. That means that they are only available in the paid version. Yes, and to speed the process of drawing, most of the tools have a keyboard shortcut. Although I recommend to learn this once you are familiar with the tool, I attach in the description of the video the list of the default shortcuts for the most used ones. At the right, I can see the panels that have different functionalities. I will explore them in detail during the tutorial, but for now let's see some of them. The first one is the entity info. It shows information for the element selected. The parameters here differ in the type of object, and if I select a solid, you can see there are specific parameters, and one of them is the volume. The instructor shows us how to use the tool currently active. Now the information is for the select tool, but if I want to draw a line, look, that is teaching us how to use this tool instead. On materials, we can set specific colors for our surfaces. Usually we do this with the paint tool. Pick a color and then click to paint one of the boxes. Here we can see display settings and so on. To close the panels, I have to click on the cross over here, or if I just want to hide all the panels, I click on the arrow and then they all open once I click again in another panel. In this chapter we will start drawing 2D objects. Probably the most simple tool in SketchUp is the line tool, and to use it, it's pretty simple. However, there are a few tips that you must learn from the beginning in order to be more effective while drawing. So, to draw a line, we can activate the tool by clicking on the pencil at the toolbar. Then, the process is the following. Click for inserting the first point. Make the line as you wish, and click again for the second point. That's simple, as you could see. Then, look, I can insert a second line continuing from the same point. That's useful if I want to insert a lot of lines together. Let's place it here. And then, when I want to stop drawing lines, I just press Escape. Okay, these two lines, as you probably expected, didn't have any specific length. I'm going to press Ctrl Z twice and repeat the process. Place the first point, and now look. Notice that the pointer snaps when I am close to the direction of the axis, in order to make the lines parallel with them. This function is called linear inference, and there are also more types here that we will explore during this tutorial. Okay, let's place it along the green direction. And instead of clicking right away, look at the measurements box. There you can see the current length of the line that I'm drawing. And because it's a bit hard to specify a length only by moving the mouse, it's better if we insert the value that we want. This time I'm going to type 2000, which is in millimeters, the units of this project. After, I keep drawing another line. This time I place it along the red axis with a length of 1000. And for the third one, I can connect it with this first endpoint. These are point inferences, and we should use them to draw with accuracy. Now, after drawing this first figure, let's start exploring a little bit what we can do here. First, notice that when you draw lines to form a close boundary, a face is automatically generated. Then, this is also important. I am still with the line tool, and by pressing Escape, you can see it doesn't exit a command, like what happens in AutoCAD, for example. Here we always need a tool active, even it's the Select tool. So for that I have to click on the arrow or press its keyboard shortcut, the spacebar. Now I can click on one of the objects to select it and hold Shift if I want to add a second object. To erase them, I can press delete. And you can see that the face also went away, as it's mandatory to be limited by lines. This is important to know. Okay, go back and let's start using the panels. I'm going to open the entity info, and once I select a line, you can see that dimension is shown here. Then let's select the face. This time it shows up the area and the material used. There is a material for the front and for the back, and you can see that it comes with the default ones. So let's learn to assign a new material. It's easy. I have to click on the Paint tool and the Materials panel automatically opens. By default, on the template, I only have these colors to choose, but for now it's fine. Let's paint a triangle with this green. Click, and then click on the surface, and you can see that it's simple. Okay, now I recommend you to start practicing drawing lines, and for that I have prepared these exercises that you can get from the link in the description of the video. So pause the video right now, save the files in a folder in your computer, then in the SketchUp application, go to Open, My Device, search for the file, this time is the chapter 1, open it, and finally save it in your projects. Okay, I'm not going to solve entirely the exercises here, but I want to give you some tips to help you during your practice. Let's start from the one below. Here, we have only orthogonal lines. We will use the line tool to start drawing, and suppose I want my first point aligned along the red axis with this endpoint. I just need to move the cursor along that direction and this dot line displays. Easy. Then click where you want to start. Now I can make the lines as I explained it earlier here. The first one, let's align with the green axis. Then the second one is 1200. Then 800. 600. And for the next one, let's make it different. If I hover the first endpoint and move to the right, you can see I can also snap this intersection point of the red and green axis. Finally, I can close this polygon by connecting with the first point. Another way of drawing orthogonal lines, which is not my favorite but it may work for you, is locking inferences with the keyboard. I'm going to draw the same figure, and this time I press the left arrow key to restrict the movement along the green axis. And the line is also now bold. Look that I can move the cursor anywhere, and the direction of the line is still vertical. Then I type the length and press Enter. For the next line, I'm going to press this time the right key to constrain along the red axis. So, I invite you to complete this figure using this method. Then, of course, you can use the way that it works best for you. The advantage of locking these directions is when I need a point aligned with this endpoint, for example, I can click directly there, without the need of following the tracking line. Let's move to the next exercise. The triangle, it's easy. Just draw it using any of the techniques I have taught to you before. Then the small rectangle over there, notice that it's located in the intersection of the green and red axis. With the knowledge you already have, you can do this by making a temporary line, snap the point to detect the intersection and draw the lines normally, and at the end you can just select the line and press delete. Another way to do this is that we don't need actually to draw that extra line. So As soon as I drag to the left from this corner, I can press Shift, then you have to move the mouse, it's important, to constrain this tracking line along the red axis. Then look, if I click on the corner down here, look that it says Constrained on line from point. The new line starts from that red square. Now be careful. Do you remember there is also the blue axis to make objects in 3D? Sometimes, depending on the rotation of the viewport, two of the axes may get very close to each other. And that's exactly what's happening right now. It may look that I'm drawing in the same direction, but because the line is blue, I can see that it went to the third dimension. So, to avoid the axis overlapping, we can rotate a little bit the viewport, and it's going to be easier now. Next example. I want to introduce another inference point. We start by drawing this line in the bottom. It has 1000 meters of length. And then I want to draw a new line exactly from the middle. By moving the cursor along the line, you can see that the midpoint highlights. Basically, if I click right now, it starts accurately from the middle. And then let's make this new line with a length of 500 millimeters. Okay, now I want to show you a particularity here in SketchUp. When you make a new line intersecting another, the first line splits in the intersection. This is something that differs from some CAD programs like AutoCAD. And due to that, I'm able to find the midpoint of the new segment that was created to draw the next line. Then continue drawing the remaining parts of this exercise, and don't forget, when using linear inference, make sure it's using the right axis, because now this line is blue, which corresponds with the blue axis. So sometimes I have to rotate a little bit, and then finally the green axis highlights. On the last example here, I want to show you the parallel perpendicular inference. After drawing this triangle, I'm going to draw this line first, and then the next diagonal line, you can see that it's going to be parallel with the hypotenuse of the triangle. I hover the line and then move slowly until a parallel line tracks, which appears in magenta color. And in the same way, I can also detect a perpendicular inference with that line. So I just need to complete this figure using the inference points. In this chapter, we are going to explore the arc tool. It's not hard to use it, but there are 4 different ways, and they are all displayed below the line tool. So, I have prepared these exercises for you to practice, but in this tutorial, I will just teach you how the tools work. Let's go! I'm going to activate the option above, Arc. And the process is, click for the center point of the arc. Choose the first point, and in this case, I'm going to follow the red axis and type a specific distance for the radius, 2000 millimeters. Then I need to click for placing the second point or type a specific angle. Here I'm going to move the pointer closer to 90 degrees, and you can see that it snaps to that point, which is a quarter of a circle. And then I'm going to draw a line from there until the center, using that inference point. And as you can see, this could be a perspective of a door in a floor plan. Then, if I want to connect the points below with a line, it creates a face automatically. Important note: when I type the angle, it's along the direction where my pointer is. Even I am drawing clockwise right now, I need to type a positive number, this time 30. Now let's move to 2-point arc. It's the second icon and the shortcut is A. I'm going to draw an arc between the extremities of this line And then I need to type the bulge, which is the distance from the middle of the 2 points and this height. For the example here, I will type 500. Now look at the next example. This time I want to add the same 2-point arc, but on the other side. First I click in the first point, then, as I cannot snap the second point, but you can see that if I drag the pointer along the edge, I type 700 and I can make the second point start from there. Finally, just need to specify the bulge. The third type of arc is the 3-point arc. This one is very intuitive, as we only need to click on 3 points and the only possible arc generates. Let's do it for these 3 endpoints. I'm going to choose the tool, and finally I click on all the points. Now I want to show you a second example, and the arc will have this shape. The last type of arc is called pipe, as we create something like pizza slices, as you can see in the example here. The method is the same as for the standard arc. We have to specify the center point, then I have to place the first point by specifying a radius, and for the second point, I'm going to type the angle, which is 30 degrees. The difference here is that I create an area with the segments that border the arc. For the second slice, I picked the same center point, and this time you can see that when I'm close to the direction of the last line, it snaps to it, so I just need to type the length. Then I also make a 30-degree arc. And finally I just need the last slice, and the angle is again 30 degrees. And look that it matches the green axis, as the total angle is 90 degrees. Now, I want to show you a characteristic about arcs that also applies to circles. After making the arc, you might notice that it's actually a group of segments of lines. When I select it, now this one was split in two because of the intersection with the line, and go to the entity info, you can see the number of segments here. Now there are 8, and in case you want to confirm, you just count them. If I increase the number to 20, the segments become smaller, and it's harder to notice the vertices. Of course, if I change it to an even bigger number, the arc now is very smooth, looking perfect with this zoom. Then I set 30 for the arc at the left, remove the line, and look that both arcs automatically merged, and the number of segments is now the addition of the 30 segments from the left and the 60 from the right. Now you may ask yourself, for what reason SketchUp divides arc and circles in segments? Good question, and this is regarding the usage of RAM memory. If you have a lot of circles in a project with a big number of segments, the workflow may slow a bit. So, the point here is to specify the minimum number that it still looks like an arc. Another important tip: the higher the angle, the higher the number of segments we should use. In the next chapter we are going to start making some shapes. And let's start with the circle. So this one is pretty easy. Just click on the button below the arcs and find the icon there. I just need to place the start point and specify a radius. Let's use 200 mm. Then, like the arcs, I can see the number of segments there on the entity info, which currently is 24. So, in reality, what we draw here is a regular polygon, and the value means the number of edges. Look, if I change the number to 5, now we have a pentagon. If I change it to 6, we have an hexagon, or to 4, a square. Now, one tip here. When drawing the circle, I can increase or decrease the number of segments or edges by pressing Ctrl+ or Ctrl-. Actually, there is also the Polygon tool, and it's a bit better to use it to draw any kind of polygon, like hexagon, octagon, decagon, etc., because there are two ways of drawing. The default one is inscribed in a circle, and if I press the button Ctrl, we switch to circumscribed about circle. Rectangle tool. It's the first icon in the same group of tools, and the way to draw it is simple. Put the start point is one of the corners, then type the value for the red axis, comma, and specify the length of the green axis. Another way to draw a rectangle is placing the start point in the center of the figure. Press the button Ctrl, click for the start point, and then to specify the length of the sides, it's just the same process. Also, while drawing, when the shape is close to a square, look that it snaps to have the edges equal. But this time, let's draw a rectangle with 500 by 600 millimeters. Now, it's time to start modeling objects here, and probably the most important tool for doing this is push-pull. The way it works, it's actually very simple. However, there are a couple of constraints that's important to be aware of them. Go to a face, click on it, and you can see I can generate a specific height along the blue axis. I type, for example, 500 millimeters, and now we have a solid. Then I can do the same for the circle. I click to push it, type 1000, and this time this is a cylinder. Now let's draw a line in the middle to divide this face in two. Then I can also add an arc here at the top. So if I use push-pull in one of the faces, it only applies in that one. Then notice if I want to do the same for the one next to it, up to the height of the connected solid. So I have to click now, but it's not a problem because then I can push it further the height that I want. The face where I made the arc has the same constraint. I cannot push it further the connected solid, so like before I have to do the process twice. Now let's learn some important tips. I cannot use push-pull in lines. Suppose here I want to make a face perpendicular to the green-red plane. It doesn't work. What I can do here is connect a line between these 2 points to make a triangle, and now I can pull the figure up or down. If I erase one of the faces, for example, select this one and press delete, I can see what it is inside. But of course, now this is not a solid anymore. They are only 4 faces connected to each other. But to convert this to a solid again, it's still possible. I can draw a line in one of the edges at the top and look that the solid is brought back again. Okay, now let's see the tool Offset. This one works for faces and also for lines, but in this case we need to have at least 2 of them connected. But first let's see how it behaves for faces. I'm going to click in this area, and what this does is copying the lines in a constant distance. And it's possible to offset this polygon inside or outside. Let's say I want to offset inside with a specific distance, for example 50. Okay, now let's try to offset these lines. And it looks like that I cannot. Because in this case we need a different method. We have to select the lines first and then activate offset. Now I pick up a point and then I type an offset distance of 100 millimeters. Now look at this different example. This time I'm picking this point. And notice also that the offset line depends of the distance from the original lines. In the second example, as there are more segments here, look how it behaves for this situation. Before proceeding to the next tool, follow me, I want to make a short introduction about drawing in the third dimension, the blue axis. We are going to make this example that only has lines. I hover this point, drag to the right, and start the first line along the green axis, which has a length of 800 millimeters. Then the next one is along the red axis, and I'm going to type 700. Then, as I need the next line to go up, I press Escape, click in the point, and then find the blue axis. But as it's too close to the green axis, in order to avoid clicking in the wrong moment, I'm going to rotate the axis a bit, so it's going to be a bit better. Type 800 and press Enter. Then the next line is parallel and has exactly the same distance as the line below. When I snap to the red axis, I press Shift and click on the endpoint below. Then for the last line, I'm going to use the same method, but along the green axis. Okay, I have finished and you can see both figures are identical. Let's go to the next example. Here, I have a circle and a line along the blue axis that starts from the center. This is easy to draw. I'm going to use the circle tool this time. Hover the center and drag along the red axis to place the center of the new circle. Then type the radius, which is half of the diameter, 400 millimeters. Then for the line, it's better if we hover the boundary first, so it will be easier to find the center point. Then draw this line with the length of 600 millimeters. Now I want to show you the Follow Me tool. I'm going to draw another line to join to the border of the circle. It doesn't matter the location. And then connect with another one to the center in order to form a triangle. Then I go to this icon and find the Follow Me tool here. Let's select the face, and I'm going to make a solid by following an arc, and if I want to make a cone here, I just follow all the border until I reach the start point again, and I have now this beautiful solid here. Now let's see the next example. We are going to use this figure, then I'm going to apply Follow Me to model this polygon around the circle, which its center point is outside of that figure. Yes, the Follow Me tool only works when after picking a face, we drag the cursor along a path, and it can either be lines or arcs. However, for better results, try to drag the pointer as closer as possible to the path, so the extrusion is going to be easier. Here, for example, I cannot do anything until I put the pointer along another object. In this case that I have a rectangle below, I can use Follow Me in the same way as I did for the circle. Then if I stop anywhere, I can continue later creating a second solid next to the former one. One important tip: it's not required for the face to be perpendicular with the path. If it's tilted a bit, like here, I can still model it along the line. And even the path line doesn't need to intersect the face. In this situation, I model the figure using the perpendicular distance from the line. The next group of icons you can find below are only used for solids, and they are only available in the paid version, except the first one, the outer shell. But anyway, I will skip it for now, as below you can find other basic tools which, in my opinion, are more important to learn when you are starting. They are the tools Move, Rotate and Scale. Let's start with Move. After clicking the command, if you had ever used AutoCAD, you realize that you cannot select the objects to move, and instead I have to click directly in a point. The problem is that in cases like a polygon, I am deforming it, so I have to use a different strategy. So, to move one or more objects, I have to select them first, and then activate the tool. This time I'm going to press the shortcut, which is M. Click on this endpoint, and let's move the rectangle towards this corner of the figure on the left. So it's easy, as you can see. Now, this also works for moving lines or other objects which are located on faces or inside other figures. For example, this line, I select it, activate Move, click on the endpoint, and let's put the line in a new position 100 mm above the green axis. However, there could be a problem if I want to move the line to the sides, as once again I'm deforming the face. This happens because the line is intersecting the edges and the Move tool does not disconnect them automatically. On the other hand, it won't be a problem for objects drawn on faces when they don't intersect anywhere. One example is this little line that I just draw, and the second example can be this circle, which by using the center, and sometimes it's a bit hard to snap with the cursor, you have to do it slowly. And I can move the figure in a specific distance, as you can see in the screen. Copy. The copy tool does not exist independently in SketchUp. It's actually an option inside the Move tool. It works similar. I select these objects, activate Move, and now if you look at the status bar, I can cycle between Copy, Stamp and Move by pressing the button Ctrl. So I press Ctrl only once, and now you can see also this cross below. I can copy the objects by clicking on a point, and then let's place them, for example, 500 mm up. Now I'm going to show you how to place an array of the objects. I will repeat the process, but this time I'm copying the rectangle along the red axis. And if you forgot to press Ctrl, you can do it now, it's not a problem. Put 500 again for the distance, then right away I'm going to type a number, for example 2, followed by the letter X. And what happened was, it multiplied by 2 the copy of the objects. Next, let's select the 3 rectangles, and I'm going to copy them, and don't forget to press the button Ctrl, 500 mm up, press Enter, and this time I will type 4x to have 4 rows of the copied objects. Another technique of making multiple copies of objects is between the original and the copy. For that, I just have to type slash and then a number. If I put 4, then I will have 3 more copies between the circles. Let's move to the next tool, Rotate. This one, it's also very easy to use. This time we have this triangle as our example. Choose the tool. It's below Move. Then select a point, and you can see that the position of the ruler defaults to the blue plane. Then select a second point in order to set the start angle of rotation, and click again for confirming the new position of the triangle. In the case I want to rotate 90 degrees from the same point by starting from the green direction, I do this way. Now let's draw more lines in order to have a component in the third axis also. I'm holding Shift to don't lift away the green axis, click in this point and connect here. Then I pick up again the Rotate tool, and you can see how the plane of rotation switches. By moving the pointer just a little bit, I can switch easily between the blue and red planes here. However, why doesn't it detect the green plane? When this happens, we can use the arrow keys to choose the plane of rotation. The up arrow is the blue plane, the right switches to the red plane, down is the plane according to the objects, and left is the green plane. So let's click right now to rotate along this plane. Another tip, you can press the button Ctrl to make a copy of the rotation that I'm going to generate. In this case, I hover this endpoint, go to the left and make the rotation how you wish. Scale. Let's learn how to scale in SketchUp for the web. For that, I'm going to use one of the exercises that I have from chapter 3, this one. First, I'm going to copy this figure and select all the elements including the dimension lines. Press Ctrl to copy. Click on this corner and copy everything along the red axis to the right. Next, we are going to use the Scale tool, which is the icon located here. Now notice, this yellow rectangle with green grips appears around the selected elements. This is how the Scale tool works. If I click on one of the corners, I resize the figure proportionally using a scale factor. Notice that the opposite corner stays in the original position. If I set 2 for the scale, look that all the lines will measure now the double that it was before. Therefore, if I pick another corner grip, I change its position and it's the opposite corner that is not moving. By moving the position of the grids in the middle of the edges, this time what I resize is along one of the axes, the red axis in this case. And look that the figure deforms. Now, 2 quick tips. If I press Ctrl once, I toggle to scale the objects about the center. If I press Shift instead, I apply to the grips on the edges also the uniform scale, in the same way it was working for the corners. Other reason that we can use the Scale tool is with the proposal of converting a circle in an ellipse. I pressed the shortcut to activate the command S. I'm going to change the dimension along the red axis. And now we have here an ellipse. Tape measure. This tool is very important while modeling our projects, because we can set points with specific distances. When we click on a vertex, we can set points along an edge separated in specific distances, so later we can draw from those places. Another way of using this tool is by picking a line instead, and then we can add guidelines to draw certain figures between them. And one example very useful is when modeling a house, for example. Here I use these guidelines to draw the frame of the windows. The procedure was the following. I put horizontal and vertical guidelines in order to have the exact area of each window frame. Then I drew rectangles easily using the intersections. Dimensions. Below tape measure, we find the tool to place dimensions. It's a very intuitive way of doing it. We just need to click on the icon and then pick up 2 points to place a dimension line measuring the distance between. we will decide in which direction we want to place the dimensions. And as you can see, they snap along one of the axes. So let's place it along this direction and click when you are happy with the position. Just click right away on the next 2 points, and suddenly you will find it easy to snap in the same direction as the previous object. Okay, now let's place the next dimensions along the wall, and we are going to check out how to edit them. Let's go to the right panel and click on Entity Info. Now, it doesn't show anything because I don't have any object selected. So, I need to pick up a dimension. Now look, there are several parameters that we can edit. And let's start with the first one, the text. It displays the actual distance between the endpoints, and this application does not allow me to change it. Below, we can change the font type and the text size. For example, if I want to increase the size of the text, I can set a bigger value, and you can notice the difference. But look that it only applied to the dimension of the selection. Basically, to change the size of all dimension lines, we will have to select them all, and then if here it displays multiple fonts, just set the type first. The one by default is Open Sans, and finally change the size. Then if I want to insert another dimension line, it comes with the same settings as the previous ones, but there is a way to change them, and it's in Model Info, which is this icon at the right panel. Here we can change the settings for the units and text that we insert in the drawing. The first one is the units section. At the top we can change the units used here. Above there are the formats for imperial units, and below the metrical units, millimeters, centimeters or meters. Now if I change the current format, the dimension lines update automatically, as you can see in the drawing. The next part is for the precision. We can set from no decimals, 1, 2, etc. Then we have a parameter for length snapping. It indicates if we want to snap lengths when drawing our objects. Now this is important. Notice that before the value was set to 1 mm. And once I was changing the format, the snap interval was also changing. And when I picked up millimeters again, the value is now set to 1000 millimeters. So be careful to look if the value is the one that you want. Now I'm going to change the snap interval to 10 millimeters. And when drawing a line, you can notice the lengths vary now from 10 to 10 millimeters. Then there are also the angle units. Here there is also the precision and angle snapping. And for example, if I make a line and then an arc that I need to set the angle, I can see I only have 1 decimal and I can snap every 15 degrees. However, the snap here is not very noticeable. So I personally don't care too much about the angle snapping. I simply type the value that I need directly. The section for the text, I can set the default dimension style for the new dimensions that I insert. And this does not apply for the existing ones. As you can see, nothing is changing unless I click on Update all the dimensions. Now yes. Here we also have settings for alignment, and the symbol of the screen aligns the dimensions to my screen, no matter the rotation of the viewport. And the others align the text regarding the dimension lines. Finally, we can choose the style of the endpoints here. Text. We can add text with the leader to make annotations in our drawings. Simply click on this icon, then click on a point, or in a face. First, we position the arrowhead, then click again to place the text. Now the text by default can be the coordinates of the point, or as this is a face, it's the area in square millimeters. Okay, because we don't want this, we can erase all the text and write what we want. For example, text1. Now, to edit its properties, we select the object and go to the entity info. Like dimension lines, I can edit the font and text size, but also the type of arrow I want to use. To change the color, I can click on the material, and this time let's select this white, for example. Then there are also some specific options when we click in the selected text to access the right button panel. We can edit the text. We can change the arrow. This we also can do on entity info. And regarding the leader, we can hidden it or change to view based instead of push pin. The difference is that view based may not be always visible as they can go inside other drawings. Instead, with push pin, the leader can rotate a bit in order to have the text always visible. Protractor. This tool is similar as the tape measure, but we are going to use it to make diagonal guidelines by specifying an angle. Let's show you an example. Click on the icon. Pick up 2 points. It can be those corners of the window frame. Then I can draw a guideline with an angle. I'm going to set, for example, 35 degrees. Then let's add another guideline, but from the other vertex. And this time I set 50 for the angle. Now suppose I want to make a triangle here, and you can see that it's going to be pretty easy with the guidelines. At the end I can delete this segment, and if I want to push this area to my side, I'm going to use push-pull to create the 3D element easily. Axis. We can change the position of the axis to any point that we want, and it's simple. Click on the tool which is below Protractor. Then I'm going to click to set the new origin of the coordinates, for example here, in the corner of this box. Next, place the new direction for the red axis, and finally the direction for the green axis. And notice that I could switch the direction with the blue axis if I wanted. But anyway, I'm going to use the same directions as before. I click here and it's done. To reset to the default position, I have to click with the right button in one of the axes to open this menu and then click on Reset. Now I am in the default origin again. Going back, if the menu that opens is different, I should try again until the menu for the axis appears. But look, if I click on the red axis, it's not working. Why? Because I have a guideline overlapped, and I'm opening the menu for the guideline. Basically, in this case, I must click on one of the other axes. Divide. I'm going to draw a line with 1000 mm of length along the red axis. Then I'm going to select this object, I click with the right button and go to Divide. With this operation, I can divide this line in a certain number of segments. Look, as I drag the pointer along the line, we can see previews of the line divided in a certain number of segments. And as I'm moving towards the center, the number decreases. Next to the pointer, there is this label showing the number of segments and its length. So, if I click now, I divide in 3 segments, or instead, let's type a value, for example 6, and press Enter. Now I have 6 segments, and I can take some advantages from that. for example, using the endpoints to place other lines. It's also possible to divide arcs and circles. This time I'm drawing a quarter of a circle using the center point and a radius of 500 mm. Now I click for the second point. I'm going to select the object, divide, and as you can see, I'm doing the same as before. I'm going to click to place 4 segments. Then I could make radial lines to connect the segments to the center. In a circle, the process is identical, but if you look closely, you can see some points out of the circle because, as you remember, circles are actually divided in edges. So, if I divide the circle in 7 segments, the edges actually change to match the points of division. Weld edges. With this ability, I join lines and arcs that are continuous. Basically, after using divide, this is the way back, to bring back the object how it was before. The previous line, which I divided in 6 segments, I'm going to select everything, right-click, go to Weld Edges, and now I have a single object again. And this also works to join connected lines with different directions. Then, after applying Weld Edges, I convert them to a single object, and now this is considered a curve in SketchUp. Then I can apply, for example, offset with just a single click to select the curve. Be aware, if I have an intersection of lines, then I try to weld the edges. Look that this only works until I reach that junction, and the other segments remain 2 separate lines. How to select objects inside the face. Now let's look at this example. I want to copy these circles to the intersection of the next guidelines. Clicking on each object one by one just takes a long time. So the best is using a selection area. However, if I open the selection from the right to the left, look that I select everything that is touched by the area, so it doesn't work. Instead, if I select from left to right, only the objects that are totally inside the area become part of the selection. Now I can use the command move, press Ctrl to switch to copy, click on the center, and then drag to the right slowly and then click again in this intersection. Flip. With this function, we can flip drawings that we select. There are 3 options. And first, I'm going to flip along the red axis. So this is the result. And as you can see, the rotation imaginary line is in the middle distance of the objects. But if I add the dimension line on the right side and select everything, that is also considered. That's why the drawing itself is now in a different position. If I select to flip along the green axis, now the drawing is facing down. Okay, I want to show you a tip. Let's learn how to make a symmetric drawing by using only half of it. So in this situation, I can copy these objects to the right, click in this point, move along the horizontal direction, and place them here. Then apply flip, move from the corner to intersect the first drawing. Then I just need to delete the line separating the 2 figures, as both faces merge. Make a group. In this example, the elements here are lines and faces, but we can group them to a single solid. It's simple. Select all the objects, right-click, and finally make a group. Then, if I want to bring the faces and lines back, with the right-click panel, I go to Explode. Now I'm back to the original geometry. To calculate an area of a face, I go to Area and then Selection. Here you can see it on the screen. But anyway, remember that the area is also shown on the entity info for a face. In this chapter we will cover the panels here in SketchUp for the web, and I'm going to start with the materials. In this example we have two solids. However, regarding the type of objects, in the one at the left they are lines and faces, and this one at the right, it's a solid group. To add a material, we need to go to the Materials panel and select one of the patterns which come by default in this project. As you can see, some are just colors or gradients, while others are patterns that represent specific materials. There are roofs, pavements, water, sky, and so on. I'm going to select this one and place it here. Then I can do the same for the other faces, and for this one let's choose one color pattern, brown. Now look, when I add a material to a group, I apply it for all the faces at the same time. This one that I have chosen is a pattern with transparency, that's why I can see everything that's inside. Then later, if I want to change it, I can do it easily. Now, aside from the materials loaded, I can browse more if I click in this symbol. They are grouped by categories, as you can see here, and there is a bunch of materials to explore. Let's open the water-related materials, and I'm going to choose this one. Now pay attention to this important note. The patterns with this kind of division, a lighter and then a darker side, mean that this material is transparent. Yes, and in the category Glass and Mirrors, you can find several of this type. It makes sense, as usually we can look through the glass to check out what's on the other side. Components. These are drawings from different authors that we can add into our model. Here I can see the components that I already have in this project. By default, we have only this one, the model loaded by SketchUp. It's this person that we use as a reference to understand the size of our objects. Here I can edit its properties. The name, the description, this person named Ty is actually a support manager of the SketchUp team. There is a short description about him here if you want to read. And then there is the position of the object. Notice that even I change these parameters, it only affects the next object that I insert, as you can see now. In the next panel, I can access to the 3D warehouse. This is the place where people can share their models in the SketchUp community. All are free to use. And you can also upload your own creations here. It's organized by categories here in this tab. Let's use, for example, interior design and then in subcategory kitchen. Finally, I'm going to choose one of these drawings, this one. Click here to download and place it on your model where you desire. Finally, it stores on the components section, here next to Ty. Styles. We can change the way that the objects display in the drawing. This panel is organized in the same way as the materials panel. Here we have the styles already loaded in the model. At this moment I only have this default one. But we can find more in the search tab, and also you can see they are grouped by categories. The ones above are the assorted styles. Some here are sketchy styles, dark styles, etc. And then the next tab, we can find the color sets. Here, the first one uses the default colors. And then there are styles that switch some of the colors. Now, the materials that use patterns like the roof and the grass here don't change the colors. Then there are default styles, where you can find a wireframe or an X-ray style, photo modeling, sketchy, and so on. Each time we apply a new style, it goes to our model section. So it's easy to use them again if necessary. To edit a style, we have to click on this icon, but this is only available if we upgrade our account. Anyway, I think when we start with SketchUp, the ones available here should be more than enough. Tags. This feature is useful to group several parts of the project. They act a bit like layers, so let's have a look. First, we need to set a new tag, because there aren't any by default. I click on this symbol and set the tag name, for example, Support Drawings. So, the tag is still empty, hence we need to add objects there. Let's select all these objects. I'm going to click on these three dots and then on Assign Tag. So the objects are assigned to this tag, and if I turn it off, the objects hide from the viewport. Then let's create another one, called Boxes. Oh, and even the objects are selected when I'm creating this new tag, they don't assign automatically. So I have to do the same as before, select the objects, and assign to the tag Boxes. We can apply colors to the tags here by clicking on this button. In that way, we can distinguish which drawings belong to each tag. However, objects that are not assigned with the tag were also colored. That's what happened with this house and the field that shows in red. To avoid that, it's simple. Just create another tag. And to select the objects easier, turn off the other two and place those objects there. To change a color, just click on Edit Tag and select the one that you want. Then there is also the dash pattern here, however it's not available on the free version. Scenes. In this panel, we can select a specific view of the viewport. We can play around with these different views and it won't be hard to understand. But basically what we have here is the top, back, front, left and right views and the 4 isometric ones. Also remember that SketchUp uses by default a realistic projection. For example, even these two dashed lines and the green axis are parallel, they seem to connect at the horizon. Exactly the same view if we were standing at this position. That projection can also be controlled at the field of view. The higher the number, the closest to the surface is our perspective. But I recommend to not put this value too high, as then it becomes a bit messy to rotate and zoom the screen. So I think it's fine around 30. On the other hand, if we set the value to 1, we will be at a parallel projection, which is unrealistic, but better to understand distances. And if you are familiar with AutoCAD, it's exactly this projection it uses. So, as I said, By default, SketchUp uses a perspective view, because this button is turned on. But it's okay, I can change to a parallel projection. And now, all those views will be exactly like in AutoCAD. So if I want to use a 2D perspective right now, I can use a plan view, for example the top. And now, this is great if I want to draw only 2D objects. And the first 3 exercise files that I provide along this tutorial use this view. So don't forget to download them if you haven't done it yet. Display. This panel has features that control if certain elements display on the screen or not. When we open the panel, the first section above is regarding unhiding elements. And, as you guess, we can only hide something that has been previously hidden. So, to hide elements is simple. I'm going to select those guidelines, for example, right click. Didn't work. I clicked on an empty space. So try again. Yes, you have to click exactly on the object. Now let's click on hide. Then I'm going to hide this box, which comprises lines and faces. And the next one is a single geometry. I'm going to hide it as well. Let's return to the panel. If I click on Unhide all hidden objects are visible again. Now let's do Ctrl Z to undo this step. And in the View section, there are 2 checkboxes to allow me to see my hidden elements. If I click on Hidden Objects, now the hidden solids, which was only one, show in the screen. And if I put a tick here, I can see the hidden geometry. Notice that it's easy to understand which elements are hidden and which are not. Then I could select, for example, these guidelines and click on Unhide Selected, so they are displayed again. There is an option to show or not section planes and section cuts, but for that I need to draw a section in this project. The icon is located here. Now to draw a section, I can choose a plane. I'm going to press the right arrow key to lock to the red plane and place it on this point. So the section is created. Then if I remove the tick from this box, the section plan hides, as you can see. On the other hand, if I untick section cuts, the section plane is still there, but everything remains visible. The last options are for showing or not the axis and the guidelines. I could also delete all the guidelines here, but as long as I can hide them whenever I want, I don't think it's necessary to do this. I can turn on shadows, set the time and the date, and there is also an option to set a fog and a background color if I want. So it was everything in this tutorial. Thank you very much for watching, and don't forget to subscribe to CAD in Black to check out the complete playlists. If you are already a follower, I think we will meet again pretty soon.